This is Algebra 2, Lesson 8.4, Random Variables and Expected Value. A discrete random variable is an outcome that's countable, would be the easiest way I think to put it. So 1, 2, 3, 4, countable, or 10, 20, 30, countable. We wouldn't want anything like red or heads. That's not countable, they don't have a value to them. When we're doing expected value, we need to have a value, a numerical value, not a categorical, like red or blue or heads or tails or something like that, because we're going to be doing the average. So to calculate our expected values, we will first take the outcomes, the discrete random countable outcomes, multiply those outcomes by the probability of each outcome, and then add them all together. So I have a table that I put on the exercises to try to make them a little bit easier. The first example says, when Nate goes to visit his grandfather always gives him one bill from his wallet. Nate peeks in the wallet beforehand and sees 8 bills. 2 1s, 3 5s, 2 10s, 1 20. What is the expected value of the bill Nate will receive? Okay, so first we need to know what are the possible outcomes. He can get a $1 bill, a $5 bill, a $10 bill, or a $20 bill. Now that we have all of our outcomes, we need to know what the probability of each outcome is. Well, what's the chance that he's going to get a $1 bill? There are 2 singles out of the 8 bills. What's the chance that he's going to get a 5? There are 3 5s out of the 8 bills. Chance of a 10 is 2 out of 8. And chance of a 20 is 1 out of 8. We have the outcomes, we have their probabilities. Now we need to multiply the outcomes times the probabilities. So 1 times 2/8, 5 times 3/8, ten times 2/8, and 20 times 1/8. We can add these all together. The expected value in this situation is 7.125. Basically, that means if we were to repeat this experiment over and over and over and over and over, multiple times, the average outcome that we would obtain is 7.125. The next example says, of the students at Twin Peaks High School, 75% ride the bus. Suppose you stop students at random and ask whether they ride the bus. What is the probability that the first bus rider you find is on the 4th try? Well, I know 75% ride the bus, so my first question is what percent don't ride the bus? 75% ride the bus, 25% do not. So if I'm going to ask 4 people, hey, do you ride the bus? And the first person's going to say nope, and the second person's going to say nope, and the third person's going to say nope, because the first rider I find is on my 4th try. So if I do not ride the bus, that is 0.25 for 25%. And I do not, and I do not, and I do. Those are my probabilities. And as we discussed in a previous lesson, to find the probability of this and that and that and that, we multiply them all together. So we have 0.25 times 0.25 times 0.25 times 0.75. And I get 0.0117 less than a 1% chance. What is the probability that you find exactly one bus rider in 4 tries? So that means the first try might be no, 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 yes, or no, no, yes, no, or no, yes, no, no, or yes, no, no, no. I would have to add those 4 responses. I already know this one is 0.0117, but this outcome is really just 25, 25, 75, 25. Even though I'm reversing the order, I'm still going to get the same answer. And the same answer. And the same answer. So, long story short, I don't really need to write this all out. All I would need to do is take my original answer and multiply it by 4. So now that becomes 0.046875. So now I'm up to an almost 5% chance that only 1 in 4 people ride the bus. My final example, a fair 6-sided die is rolled. If the number is even, you lose a point for each dot showing. If the number is odd, you win a point for each dot showing. Find the expected value for one roll. Okay, so I don't have a big table here, but I can draw one. I will win a point if it's odd, lose a point if it's even, win a point if it's odd, lose a point if it's even, win odd, lose even. Those are my 6 possible outcomes. The probability for each outcome is 1/6. Since I'm rolling a die and I have equal probabilities all around, let's just go 1/6 and kind of do that. For my bottom row then, I take my outcomes, multiply them by my probabilities. And then for my final answer for my expected value, I need to add the bottom row of my table. My expected value is to lose half a point, meaning if I repeated this several times, I'd lose a half a point. And then if I were going to play this 10 times, if I'm averaging a loss of half a point every time, times 10 times, I'm losing 5 points after 10 attempts. Moral of the story, don't gamble. You lose. That's it for the notes. Good luck on the exercises.